Welcome my dear students. Today we will start the new exercise 4.6. It is the very important and all the questions are linear equations. So my students, the first questions are given. You have to check the system of linear equations are consistent or not. That means you have to show that these linear equations are consistency or not. At first, suppose that you have to find, check whether it is the consistency. Consistency or not. That means the equations are consistency or not, you have to check. If you want to show that it is the consistent or not, suppose the equation 2x plus 3y equal to 2 or 4x minus y equal to 3. These equations consistent or not? You have to check these equations, that means these linear equations is consistent or not. If you want to show that this function the linear equations are consistent, then at first you have to show that the determinant of the matrix A not equal to 0. Suppose the matrix A is the matrix 2, 3, 4, minus 1. It is the matrix A. A is the coefficient. At first you have to write that A is the coefficient. A is the coefficient of x, y, z. X, y, and x or minus y. So these are the coefficient here represented by A. And B are the constant term. You have to write in column 2, 3. So always you have to write like this. This is the matrix A and that is the B. Always you have to write like this. Ax equal to B, like this form. So always you have to do like this. Ax equal to B and x should be in capital letters. X should be in capital letter. So my students, you have to look here. Next, after that, you have to find a determinant of A. That means you have to find the determinant of A, and determinant of A means 2, 3, 4, minus 1. So when you find the determinant, then you have to find like this. When you multiply then minus 2, minus 12, you get minus 14. This not should be equal to 0. It is not equal to 0. Because you get how much? Minus 14, and minus 14 cannot be 0. So it is a non-singular matrix. It is a non-singular matrix. So you write like this. So A is non-singular matrix because determinant not equal to 0. Since determinant not equal to 0, so it is a non-singular matrix. Okay, students, it is a non-singular matrix, and in case of non-singular matrix, it is a consistence. So the linear equations are consistent. So if you want to show that the function is consistent or not, then at first you have to find the determinant for any 2 cross 2 matrix or 3 cross 3 matrix. If the determinant not equal to 0, then it is a consistence. Okay, my students. In these cases, you can find the inverse of the matrix, and in these cases, you have to find inverse of the matrix. Suppose, so it is a non-singular matrix, so it is a consistence. And in case of the consistence, you have to find the solution. That means you have to solve, or that means you have to find the value of x and y, and that is called the solution. So my students, look here, I want to write like this. So I get the determinant how much? Minus 14. So after that, you have to do like this. I get determinant of A equal to minus 14. Next, what I could do here? Always you have to do like this form. Ax equal to B. Now you have to find the inverse of A. You have to find. So in case of the if you want to find the inverse, then at first you have to find the minor cofactor and adjoint. So in case of the 2 cross 2 matrix, I think you understand and you know how can you find the inverse of a matrix by simple method. So adjoint of A can be written as first diagonal interchange, second diagonal sign change, and that is the adjoint of A. First diagonal interchange and second diagonal sign change, and that is the adjoint of A. So my students, I think you understand what I am going to discuss here. In case of the adjoint of A, suppose you want to find the adjoint of the matrix. If you want to find the adjoint of this matrix, then you have to do first diagonal interchange. This diagonal should be interchange, and this diagonal sign will be the change. So this diagonal come first, this come this side, and this is the sign change. And I already find what? Adjoint. Now A inverse equal to adjoint of A upon determinant of A, and that is the inverse. So determinant of A is minus 1 upon 14, and adjoint of A minus 1 minus 3 minus 4 2. So I divide all this part by minus 14. So I get how much? 1 upon 14, 3 upon 14, 4 upon 14, and 2 upon 14, and that is the inverse. So my students, I think you understand what I am going to discuss here. So inverse already find here. Now what you have to do? You have to do like this: Ax equal to B, therefore Ax equal to A inverse B. Okay, you have to write here Ax equal to A inverse B, A inverse B to write. Next, I already find the value of A inverse here. This is the inverse. So Ax equal to A inverse. A inverse means minus 1 upon 14, 3 upon 14, 4 upon 14, and 2 upon 14. And B equal to 2, 3. Now, what I am going to discuss here, you have to multiply this row by column. Okay, by product of determinants, this row should be multiplied by column. If you multiply this row and column, then you get this number 2 upon 14, and these numbers you get how much? 9 upon 14. Again these two numbers you multiply, you get for these numbers. Okay, I just multiply this. Again for this row, these elements you get 8 upon 14 plus these two numbers 6 upon 14. So I get this one. Now if I added these two numbers, I mention here, I write here, these two numbers 11 upon 14 and 14 upon 14. So that is the value of x. So my students, I think you understand, and that is the value of x. So I write just here, x means x equal to, I get 11 upon 14 and 1. When you cut this into 1, or x means how much? X means you have to write like this, x, y. It is a variable matrix. So by comparing on both sides, x equal to 11 upon 14 and y equal to 1, and that is your answer. So my students, I think you understand. So I'm going to discuss what's the functions and how can you find the matrix of a determinants by using the elementary operations. So I think you understand. Next, so once again 1 to up to question number 6, just need to check this the consistency or not. So I am already discuss here. But in case of the question number 17 to question number 16, all these questions you have to solve the linear equations by matrix method. So you have to solve all the equations. This solution already I discussed in these questions. Suppose I am going to discuss the question number 14. X minus y plus 2z equal to 7 and 3x plus 4y minus 5z equal to minus 5. Next 2x minus y plus 3z equal to 12. Okay. Next, this one you have to write in matrix method. That is why A matrix is like this. A coefficient 1 minus 1 and 2, again 3, 4 minus 5 and 2 minus 1, 3. That is the A matrix. And B matrix here, all the coefficients 7 minus 5 and 12. And X matrix should be written all the coefficients x, y, z, all the variable points. Okay, my students, I think you understand. Now you have to find what? You have to find the minor and cofactor. That means you have to find the adjoint of this matrix. If you want to find the adjoint of this matrix, then if you want to find the adjoint of this matrix, then in these cases, if you want to find the adjoint of this matrix, then in these cases, what you have to do? You have to do like this, my students, minor, cofactor, and adjoint. So for all these elements, you have to find the minor and cofactor. For this, at first you have to find the determinant. So if you expand for 1, this number of these row and column cancel, you get 12 plus 5. Next plus 1 for these elements. If you write a minus, again a minus plus. Again this row cancel, 9 plus 10. Again minus 2, this row and column cancel, minus 3 minus 8. So I get 17 plus 19 and here 11 plus 22. These two 11 into 2, 22. If I added all these numbers, you get how much? 11, 18, remain 1, 3, 4 and 5, 58, 17, 16, 18, remain 1 and 3, 4 and 5. Okay, I get the determinant of A equal to 58. So it is not equal to 0. Determinant of A not equal to 0, hence inverse exists. Okay, my students? It inverse exists because it is a non-singular matrix. Okay, it is a non-singular matrix, hence its inverse exists. Okay, my students? Because it is a non-singular matrix, hence its inverse exists. So I get determinant equal to it is a non-singular matrix. Now I have to find what? Determinant or adjoint or minor. So A matrix is given by A matrix is 1 minus 1, 2 and 3, 4 minus 5, 2 minus 1 and 3. So you have to find the minor and cofactor for all the elements. Okay, now this portion you have to do yourself. If you want to find the adjoint, then at first you have to find like this adjoint, you know. At first you have to what? At first you have to that means you have to find the minor, after that cofactor, after that adjoint. Transpose of this cofactor matrix is called the adjoint. So adjoint matrix, you know, you find using this. After that inverse adjoint of A upon determinant of A. If you want to find this, then you have to write Ax equal to B or X equal to A inverse B. So this coefficient X, Y, Z. These two numbers multiply here and compare, you get the value of X. So my students, X, Y, Z. And these are all process, but here I show you shortcut, but you have to describe. At first you have to find the minor, after that cofactor. I think you know how can you find the cofactor and minor. Cofactor, minor, after that you have to do like this. And you compare both sides, you get the result. So my students, I think you understand what I am going to discuss here. Thank you, my dear students.